Okay, we are live now. So I'm going to share my screen and I'm going to start. So yes, let me, okay, this is one. So let me share my, say, okay. Now I hope my screen is visible. So let me, yes. Good evening, everyone, and welcome to another Azerbaijan Data and AI Community Meetup. My name is Ilgar Zarbayev. I'm Microsoft Data Platform Power BI MVP and Microsoft Certified Trainer and your host for today's event. Thank you for taking time to join us. Today's session is Coding But Make It Art. It's an inspiring topic that demonstrates how technology can become a creative medium. And we will explore how mathematics, artificial intelligence, actually our speaker will explore this stuff, including cloud technologies and programming can work together to create beautiful visual art. So today's presentation is quite different from a traditional software development session. I hope our speaker, Olena, will share how her passion for mathematics and art inspired her to build a system that transforms ideas into artistic sketches. So, a little bit about our speaker. It's now my pleasure to introduce the speaker, Olena Borzenko. I hope I pronounced her surname correctly. Olena is a Microsoft Azure MVP and an experienced consultant specializing in building modern .NET cloud applications. I hope in next minutes she will be giving the necessary information about herself. So please join me in giving a warm welcome to Olena Borzenko. And a little bit about our upcoming speakers. I also include myself because I'm organizing study groups under Data Days 2026 organized by Microsoft. Actually, next week is going to be my sixth last session. So you can find the necessary information about our Meetup platform, Meetup group. So next speakers are Rob McLaughlin, who is former Microsoft MVP and current MCT and MCT community lead, and also Ilan Naska, who is senior Microsoft technical trainer. So I hope and strongly believe that I'm going to welcome you at our upcoming meetups. A little bit about our meetup rules. Please mute yourself during the meetup session. So you can type your question in the chat, or you can ask this question at the end of the session, where we are going to have our Q&A session. And what else I would like to tell you is that this session is live streaming on YouTube. So if there is any material that our speaker is going to share with me, if she shares, I will share also in my turn these materials with you. So this is the structure of our session. First 4 or 5 minutes that I'm doing right now is a little bit introduction. Then we are going with Olena's main presentation. And then at the end, we'll have Q&A session. So this is information about data days. So you can find the necessary information just typing on in a browser, aka.ms/datadays. There are sessions related to DP700, Fabric Data Engineer, also DP600, DP800, and PL300 exams. So I would like here to stop sharing my, screen, and I would like to deliver stage to Olena. Olena, stage is yours, and best of luck. I don't hear you, Elena. Olena.
Yeah.
Okay,
You don't hear me because I muted my mic. Okay, I shared my screen. I'm trying to share my screen. Let's do it again. Can you see it now?
Yes, it's visible.
Okay, perfect. Thank you very much, first of all, for having me. That's always, I'm really always happy to share any sessions that relates to technology, but it makes me even happier when I can share something that relates to my passion, to my hobby. So today's session, coding but make it art, it's about everything. It's about what I do from day-to-day life. So about writing code, about designing some solutions, but it's also about how you can use it in a creative direction. So how you can create actual real things in the world, not only digitally. So I will show you, there's going to be a lot. There's going to be some visuals, there's going to be explanation of the system in general. I will show you some code, and I will also start the application so you can actually see how it works. But before we dive in, I will just say also a couple of words about myself, just to summarize it. So my name is Olena Borzenko. I'm consultant and GitHub tech lead at Xebia, Germany. I have a degree in applied physics, so I'm public speaker for more than 5 or probably like 7 years, I'm not sure already. I'm coming from software development, focusing on C# and .NET. And then, of course, it's cloud, Azure, Microsoft technologies, and Microsoft MVP, as it was already mentioned. You can see some of my social handles. You can follow me for some more information. LinkedIn, of course, it's work related. On Instagram, you can see things that are related to my art. So I mostly post only my new artworks there. You can also see a little screen. So I regularly write magazine articles to the Expert magazine that we have in our company, but this magazine is being distributed at Techorama conferences. I do write on different topics. Lately, it's been mainly focusing on art and what I'm doing with AI, GitHub Copilot, and other technologies. But I am very proud about this because as a consultant, my main work and focus is always on the consulting work. So it's a lot of different topics, a lot of different POCs and technologies. So it's really challenging to find time for personal development. So I do encourage everyone with those articles and my conference sessions, meetup sessions, to keep exploring what you actually like and find time not only for work and development because you have to do it, but also because you like it and you genuinely enjoy it. So let's start from what actually, where did I find the inspiration for doing what I'm doing right now? So as I already mentioned, I have a degree in applied physics. This means that I had to explore a lot of different physical terms and equations and all sorts of things. And of course, I had to read a lot of different books, and not only about physics, but also chemistry and mathematics. And the picture that you can see on the screen, this is something that caught my attention. This is not the real representation of an atom, but it's a structure of radium atom assumed by Niels Bohr in 1922. So it was just his idea of how it might look like. Right now, we know that it has a completely different representation, but when I saw, so this was published in one of the articles and like almost 100 years ago, more than 100 years ago. When I saw this, I really fell in love with symmetry, how beautiful and elegant this looks like. And I had this thought in the back of my mind that if I ever get to do some art, this is probably will be a direction of what I want to choose. I want it to be elegant. I want it to be symmetric. I want it to be interesting, and I wanted to have a similar structure. I left this thought for a while of having a chance to do art, but I actually always loved all the creative things. So I used to paint when I was a kid. I used to do some things with my hands. But I never had a chance to explore it properly and actually develop a skill like this. But every time when I would be exploring something on the internet, I will be fascinated with things that I was finding. And those pictures that you can see now on the screen. This was something that I found on Pinterest, I guess. This caught my eye again because it's a very similar structure. So it's again a lot about symmetry. It's a very beautiful and very elegant forms. But beside this, what really like sparked like some kind of inspiration in me, that I saw that there are some equations. again, thanks to my education, I'm not afraid of equations. And the opposite, when I see them, things becoming more clearer to me because it means that I can use them, that I can experiment with those equations, that I can also do something like this. So finding those equations were basically like a starting point for me that allowed me to think about exploring those things, exploring those shapes with my knowledge in physics and mathematics, and also trying to apply it with my professional career. I definitely, at this point of time, I definitely thought that I can write some algorithms, that I can write some code that can generate something similar. So that was kind of a beginning of this whole the whole journey that I'm still on. And another thing that was kind of like a changing point for me when I get the chance to work with a CNC machine. And for those who doesn't know what a CNC machine is, a computer numerical control, or CNC machining is the automated control of machine body by a computer. I will give you a couple of examples. What's like the similar machines, like the same principle of work. Like, for example, laser cutter or wood carving tool. They are working by the same rules, so they have the set of instructions that they have to follow. A 3D printer works in exactly the same way. It's a very similar tool. So basically, CNC machine is something that can you can use it, you can execute certain set of instructions and it can do something for you. And based if you want to carve something, or you want to use a laser for it, or you want to use the 3D printer material, you can do different things with it. Here's how it looked like. So from this side of a screen, I'm not sure if you see it in the same way as I do, but basically when you can see the machine, it's a quite big machine. It's more than 1 meter like weight and height. So this was one of my first artworks that I did with this machine. So you can see that there is a motor attached to the X and Y axis to the machine itself. We attached pen to the motor. So this was initially for the wood carving, but we changed it a little bit so we could actually use artistic tools like pens and ink and pencils or brushes if we needed to. And those were some of my first artworks that I did. They were very simple. I had to learn how to work with mediums, how to work with canvas, how to do different things. So I just took a very simple primitive shapes from 3D Max. I tried to like pull some of the segments out, try to experiment with brushes, and see how it's gonna work. I mean, I'm not gonna hide it. So first of all, it takes quite some time to actually print all those lines. So I do like the wireframe structure, but it takes really a lot of time. And it took also quite a lot of time for me to actually, even if it's the simplest design you can possibly imagine, I mean, one of the simplest designs, it still took me quite some time to get all those segments out, to find the right perspective that I liked, because I have nothing to do. I have no skills in 3D modeling. So it was really difficult to me, but I was really happy that I got a chance to work with CNC machine, because that was one of the tools that I explored, and I thought that I can potentially use it in the future as well. There were some changing moments when I kept working and kept doing more art with the CNC machine. I kept exploring different brush techniques, and I kept exploring different shapes. And the shape that you can see on the screen, that was exactly the changing moment, because the shape is called torus node. I saw the shape, I really liked it. So this tube that's been wrapped around itself and kind of forming a node on its own. And I saw that that might be something that I should explore more, because maybe I can find some symmetry in there and maybe can experiment a little bit more. So for those who doesn't know what torus node actually means and what's the mathematics behind it, it's one of the base shapes that you can find in the 3D modeling tools, but it's also a mathematic term. It's a P and Q. P and Q, those are parameters that we are using for building those shapes. It's a torus knot. It's basically a knot on the surface of the torus that goes around p times in the meridian direction and q times in the longitude direction. So you can basically think of it as how many times it's going to be wrapped around the donut and how it's going to be twisted around itself. So that's how it's basically being formed. What you can see on the screen, it's basically it has eight, so it wraps around the torus eight times, so it has a 3 and 8 numbers. It's kind of a little bit hard to wrap your head around those numbers right away, so it takes a bit of a time to get used to it. But the point is that when I found this base shape in 3D modeling tool, I really liked how it looked, and I decided that I can explore it. And also on one of the previous screens, I showed you that I found some mathematical equations, and I knew that they can be somehow related. So what we saw on the screen was equations. Those are also some kind of representations of nodes, a bit in a different dimension, but they are all related. So basically all this time, wandering around the internet and gathering some of the bits of information and inspirations, I was moving the whole time in the same direction because I was exploring different tools and different mediums, but also kind of the same thing that led me then to results that I got. So yeah, so next thing I want to show you, so this is the shape that I found in 3D Max. The next thing I want to show you is that some of my experiments with this tool before I got to coding part. So before I decided to build an actual tool using all those modern technologies, I still wanted to understand if that's going to be really a direction that I want to move in. So on the screen, you can see some of the examples of art that I made, and those are like actual real canvases, 60 per 60 centimeters. This is a base shape in 3D Max that I used, and I used different techniques with brushes and strokes and different materials as well to make those art pieces, but I really, really loved how they looked, and that was exactly the point. That was exactly the shape that I loved because of the symmetry and because of how elegant and simple it is, yet at the same time looks quite nice and complicated for my taste, of course. I know that art is very relative, but for me, it was exactly what I was looking for, and it gave me a lot of fulfillment. I also love that behind this shape, there's a lot of complexity because there's a lot of equations, there's a lot of formulas that can describe this. But at this point, I had to tell you that most of my evenings I was spending sitting in 3D Max application in program. And I was just basically playing around with different parameters, moving like those numbers left and right, trying to figure out how they influence the final shape. And I kind of was a little bit annoyed from this process because manual work is not what I like to do. I tend to automate things, especially when I see that they are repetitive. So I want to give you a little bit of input. I'm not sure if this, I will be, yeah, I think I will be able to play the video. I want to give you a little bit of insight of how the full process actually look like, so you have an understanding. That's why I hope it's gonna work. I included a little video. Yeah, I included a little video on the slides. You're probably not going to hear the sound, but that's definitely okay. I just want you to see the process itself. Yeah, okay, I will turn off I don't know if you was able to hear the sound or not, but I just wanted to show you a speed up process of how the whole art creation looks like, so you can understand how, first of all, how much time it takes, how much effort, but also how many different steps that you need to think about before you get to an actual art. So what you see now on the screen, this is one of the art pieces that I did after I built my tool. All the steps are exactly the same. It doesn't matter if I use my tool for sketch generation or not, but all those manual steps was putting on the color, and then scotch taping, and then, drawing all the lines. They are all the same, no matter what tools I use. So, but wanted you to understand how the process looks like. So this is an actual printing step when the CNC actually does the trick. So the sketch that I generate or I build in 3D Max, then I use the CNC machine to actually put it on canvas. So I hope that gives you some insights on what the process actually look like. And yeah. So now we will talk a little bit more of how and why I actually started building the tool itself. As you saw, the process of the art creation itself. I mean, of course it was in like 2 or 3x speed mode. But usually it takes me from 1 or 2 days just for an actual art. And before I built my tool, it was also taking me 1 or 2 days just to create a sketch itself, because it was a lot of manual work and I didn't like it. So at the point when I knew that I already have a good base, because I already know how to create an actual art and how it's going to look like in the end, I decided to explore more generative options for myself, because I know how to write code. I know how to, so I knew that I can maybe reverse engineer some things and actually build those shapes using my programming skills. So first of all, let's understand the difference between algorithmic, parametric, and generative art. So algorithmic art, we just have 2 equations, and it's always the same. It's always predictable. So algorithmic art heavily relies on the algorithm itself, and it doesn't matter how many times you regenerate it, it's always going to be the same result. So it's predictable. That's what makes art algorithmic art, when we have an equation, and it's when it's always the same result. Then we have parametric art. Parametric art focuses on defining a design through parameters and a relationship between themselves, and also they depend on time. So what you see now on the screen, this is an actual parametric equation for torus node, for shapes that I was using in my art. And as we can see, there is a P and Q parameters. Those are basically the amount of wraps that it's going to do around itself and around the torus as well. But also we have a T parameter, and parameter T is how it's going to change with time. So we have, of course, R, it's a radius, it's a small and big radius. And then it's basically a matter of how the shape, the tube is going to move with time. So we have those 3 equations together. They create a pair, like those, not the pair, but the parametric equation set. And this is exactly the equations I will be using in my visualizer component that I built. I mean, of course, it will be much, much more complicated, because I apply a lot of modifications to an actual torus, but the baseline is this. And then when we want to push it even further, so not only using algorithms and not only making it depend on time, so it's like parametric equations, but also we want to make it generative, then we need to introduce some kind of randomness. So this is already generative art, and we don't have to use AI to make it generative. Every time when we rerun our visual parts, like visual component, we will be able to get a different result, and it will not be predictable, because that's randomness. That's what makes generative art interesting. So basically, this is the same formula, but we introduce randomness, and then it's up to you to how to introduce it. So of course, you can just use some functions like random. In my case, I decided to wire this whole thing to AI, and then play a little bit with LLMs and see what kind of randomness they can introduce. So this is a little bit about the overall generic idea. So what was my basically thinking process? What I tried to achieve? Me as a user, I wanted to give I wanted to have a page in the browser, and I wanted to give a user input. And it can be basically any prompt. It can be like, today I'm in a very good mood and the weather is nice, or maybe today I'm so busy and I don't have a mood for anything, or I saw a really beautiful flower that I mean, it can be anything. It can be any phrase, any prompt, any description of something. The idea was basically a brain dump as a prompt, and then LLM with a certain set of instructions will pick it up, generate an art description out of it. So there is instructions laying somewhere in my application that tells like, you are a generative artist that's specialized in this and that, and your role is to take this prompt and then turn it into a description. And then out of this description, there is a different prompt engineering techniques that I'm using. So I'm using, of course, I'm also using instructions, but I'm also using a template to make sure that my schema, the output from LLM will be always the same. And that's the step when generation of configuration for my Taurus node is happening. So based on the description that is based on my prompt that I gave, I will get a very strict schema with a lot of different properties and values that I can then feed to my visualized component that's written in JavaScript and P5.js, and then get a visual result. So that was a high-level idea, and let's have a look at how it actually looks like a bit more from the technical perspective. So as a user, I'm given a user input, and I have, of course, I have API. So I have a REST API, and I have a front-end application standalone. So I have different endpoints there. So I'm making a post of my user input, and there is a part of generative chaos API. After this, I have AI application, so deployed somewhere. I'm using, until now, still it works really well, and I don't really have a need to change to a different model, but but I know that, for example, GPT-4 Omni will be deprecated or should be deprecated soon. So probably I'm going to switch to a different model. But so far, it was doing a really great job, and it was very predictable in the results. So I have two models deployed in my AI application. It's Text3 Large and it's GPT-4 Omni. One is to create embeddings for my prompts and for my art description, and the second one one for embeddings and one for an actual art description and then schema generation. So my generative chaos API, when it receives user input, it sends a request to Text3 Large to generate embeddings. And then I'm storing those, I'm storing those embeddings in Azure Cosmos DB, but also I'm using the same user input, and together with the system prompt that I have, I'm sending it to GPT-4 Omni to generate a design. And then all of this is as well going to Azure Cosmos DB. Why I'm using Azure Cosmos DB? First of all, because I really like it and I worked with it for a very long time. It's a document base. It's a document database with no schema enforced. Really beauty of it, I mean, besides all the amazing features that it has, but the beauty of it right now that you can store your embeddings, your vectors next to your actual real data. So you don't have to have a separate containers for it. You can store it all in the same file, which makes it very easy to handle and very accessible in your application. So from this, after this, based on all this information that I saved, I can also perform a similarity search. And similarity search basically means that sometimes I would be given very similar prompts, but the results will be different, meaning that I will have a different sketches available to me to choose one that I like the most. And that was the idea. I wanted to be able, so when I'm sending the request, I wanted my application in background to find all the relevant items that were generated in the past and show me for comparison that I can choose what I like the most. Azure Cosmos DB, this is everything about Cosmos DB, but I mean, of course, I can give a separate session just on the Cosmos DB itself. I'm not going to spend too much time on this, but you can just see how many different things it supports. It supports different data types. It's really nice for scaling, for massively scalable and then multi-model database approaches, but we're not going to focus on it too much. So I usually tell at least a few things about containers and the items, how they've been formed. So in my case, I'm using document database. meaning that I'm going to have a container. And in this container, you can have different items, stored procedures, or settings or triggers. In my case, items will be actual documents. So I will open it and I'll show you what we will have in those documents. But based on the API that you're using, your items will be represented in a different way. In my case, it's very simple. It's just a document, but it's going to be much more than that. So really nice thing with Azure Cosmos DB, besides all things that I mentioned, that it has integration with other Azure services. And in my case, I used to use a lot integration of Azure Cosmos DB with Azure Functions, especially when it comes to triggers. So you can react on some changes of data in your containers, in your or in your change feed, and you can do some things with those triggers. You can have different Azure functions that can transform your data or can streamline your data to other services, for example, for real-time analytics or real-time data movement with zero downtime migration time, for example. But this is just nice to know. I think Azure Cosmos DB has a great integration with other services. Definitely something to look into if you're interested in this. And then a few things why Azure Cosmos DB NoSQL in this case, because I am very flexible with data models. Again, this is my hobby project, and I didn't want to think about where do I store my embeddings, where do I store my data, where do I store my configurations. I wanted to be as flexible as possible. Vector search is integrated in Cosmos DB. It simplified my life a lot. It's optimized for AI workloads, and this is exactly what I was looking for as well. And it's a scalable and performance, because I know that in some cases, once I reach a certain point of automation, I'll be generating a lot of sketches, and I don't want to be worried about cleaning stuff up. I just want to scale and not be worried about performance. So Azure OpenAI service, two things that I have, what I already mentioned. I have different models, different model deployments. I have GPT for Omni for generating descriptions, matching functions, creating art configurations, and then text embeddings 3 large for creating vector embeddings itself. Besides models and Cosmos DB, what you will also see in my application, you will see semantic kernel. This is going to be my facilitator and orchestrator of large language models that I'm using with different plugin systems, memory storage, and planning capabilities. For me, it's going to take a lot of hassle of what function should be called. Semantic kernel is a really nice when you build in AI applications especially for where orchestration is needed. So if you're not familiar with this, I definitely recommend you to have a look at how to work with it. And at this point, I don't want to talk anymore. I want to switch to demo part, and I actually want to show you everything that I talked about. First of all, we're going to start from Azure. So what do I have on Azure? And it's a very simple setup in this case. So I do have my resource group. I do have two different resource groups, one from my AI setup, AI applications, and the second one is for my Azure Cosmos DB. I mean, it depends on you. How do you want to separate it? For me, it's a hobby project, so I wanted to keep those things separately. So here you can see the AI. So I have a Foundry, Azure AI project, AI Hub, Key Vault, and storage account. Those are being generated for you automatically when you create an AI project with Hub. And then if we will go to one of those, we will land to our Microsoft Foundry, where you can see my project overall. So this is my generative chaos AI project, and what I want to show you that I have two model deployments. So I did play a little bit around with different models, but you can see that this is my AI generative chaos. So this one I'm using for my application. These are the models that I'm using as well. So of course, I keep always experimenting, doing some more stuff. So that's why you can see other deployments as well. But what I'm using in my application, only those two models for now. So this is for AI part. There's also Azure Cosmos DB, which is in a different resource group, as I said. So just want to show you that there is nothing else except Azure Cosmos DB itself. So there's, no, sorry, actually, I'm lying. There's also a storage account. That's why it's called data. There's also a storage account that saves a preview of my generated sketches, because I wanted to have a better performance on my page, and I didn't want to render a sketch every time, but I wanted to have some images pre-saved, so it's easier for me to see the gallery. This is how it looks. This is how Cosmos DB looks like. So I have my, if I go to my Cosmos DB and then to Data Explorer, I will be able to see my container. This is a design container, and then I have items in there. So if you're going to explore any of the files, what you will see here is that, so I have, so ID, of course, of the document, it always has to be different. User input, generated description. So user input, this is my prompt. So I want a smooth, bubbly shape. It can mean whatever, but basically at this point, LLM will pick this up and using some instructions will generate a bigger and more like comprehensive description. So like image of a luminous torus not flowing like a liquid glass, it's smooth, bubbly surface reflecting a prismatic play of, so you got the idea, right? So I don't have to read the whole thing. Sorry. So this is basically how it works. You have this description, and then based on this on this description, of course, I also have a preview URL to my blog. But based on this description, we will also generate a torus config. And as you can see, config is just a JSON with a lot of different parameters, and it's quite big if you will have a look at it. So I will also show it to you. I'm sorry, I keep switching to a different page. I will also show it to you in the code itself. But what other interesting thing for you is vectors that we have here. So here you can see all the vectors that I generated for my user input. And based on this, so based on this user input, those are vectors that represented. Based on those vectors, I will be performing a similarity search. So next time when depends on the similarity score that I'm using, but next time if I will use like, I want to create a nice and smooth and bubbly shape with different colors, for example, if that will be my prompt, I will definitely get this item as a similar one. So that's the idea. That's why I wanted to have it, because I also wanted to reuse some of the configurations and see what looks best, basically, in that case, in my case. Now let's have a look at the API itself. As I said, I hope you can see the screen, but I will make it bigger just to make sure. So what we have here, I have only one controller because simplicity is the key. I didn't need to have any more. I mean, I could have separated some of the endpoints, but for me, since it's my hobby project, I thought having everything in one place just makes it easier for me. I do have a couple of endpoints. One is to generate configuration based on my input, upload a preview, preview happening from frontend. So I first generate it, and then I take the SVG, and then I send it to my, so REST API uploads it to blob storage. Get previews, and then get designs page. It's basically just a collection of all items, and then similarity search that is being triggered in the background after I send a request. If you have a look at the endpoints itself, they're very simple. All of them call a certain service, so I don't really have any logic in here. And if we will have a look at services itself, this is going to be the most interesting part for you. So I can show you the program. So program CS might be also interesting. Also quite simple. So I have, of course, course policy. So I have a setup of my Azure Cosmos DB client. So this is Generative Chaos Cosmos. There are some settings that I'm providing, and there is also client options. So what is my application name, and some of the policies that I provide as well. After that, so I also make a registration of my blob service because I need to upload my previews. And there is also a registration of my OpenAI client. So I provide an endpoint and credentials, and then it will know there are 2 models or 3 models deployed, so I will be able to use them all. Then I also have a registration of my services. It's a Cosmos DB, file storage, OpenAI, and Gallery. Those are different services that I'm using and having in my application. And if we will go to each of them, so file storage is very simple. I will start from this one. If I can do this, of course. Probably not. Okay. Okay, I'll just go here. I recently switched to making applications C#.NET to VS Code because before I used Strider. So now I'm still getting used to all the hotkeys. So if we will have a look at the file storage, because it's the simplest one, what we are doing here, we just connect it to a blob container, to the blob service, and then we have upload file, and then get file async methods. Those are very standard. There is no custom logic whatsoever. It's just getting the container, uploading file, and then saving it. And then the same is here. So from container, getting blobs, and then returning it back. If you will have a look at our gallery service, this one is like more high level. So we have a few, so this is the constructor, like that's how it looks like, but there is not, so this is just a registration of services. I can hide it for now, so it's not gonna be on our face. We have generate design async. So I will just explain you step by step what's going on here. First of all, we have a semantic kernel service that where I'm calling get embeddings async based on my user input. After I received embeddings from the user input, I will save them later as well. So as we can see, I will then add them to my design document in Azure Cosmos DB. But for now, I'm not using them anymore. So I only generated them at the design creation step. And then I'm proceeding to work with the user input itself. So after I have embeddings, I also generate design configuration itself. So I'm receiving back description and the config. So it's doing 2 things at once, but it's very similar. So it generates this expanded description of the user input, and then based on it, it also generates configuration. And then I'm serializing all the stuff and then just saving it to Azure Cosmos DB. So also no brainer here. It's a very simple step, very standard one as well. For the similarity search, again, I'm also using semantic kernel to generate embeddings. And then I'm using Cosmos DB to get similar items. We will have a look at the implementation just in a second, but that's how it works. Basically 2 steps: get embeddings, get similar items based on vectors and similarity score, and then I'm returning back all the similar items. Get design page is very simple. It's just a pagination method that gets all designs in a certain range from Cosmos DB. And then update design preview URL just also calls the Cosmos DB service to get the design itself, and then updating some information. Yeah, so update design. Update design preview URL only updates the URL itself, and then update design config only updates a config itself. So I don't know, I could have had one method for those, but I do like to have the separation. So one thing should do one thing. In this case, I thought it makes sense because I called them separately. So I don't want to update anything but preview in this case, and I don't want to update anything but torus not configuration. So that's why I have the separation. If I will have a look at the Cosmos DB service, so here I have all operations that are related to Azure Cosmos DB. So it's an actual data layer in my case. So providing partition key is always a good practice. So I do have this method here, get private partition key, and I use it in every method that I have here implemented. So we'll hide it for now. So what I need to insert design, it's a very simple. I'm getting design container and then create item async, providing partition key together with my design. This is like this is a good practice always, even if your partition key is part of the model, but it's always a good practice to explicitly say it because that improves the performance of your request to Azure Cosmos DB. If I want to get something, I'm just reading items from my container. If I want to update it, I can replace it. There are different ways on how you can update it. In my case, replacing an item works fine, so I just use this method. So here we have get similarity async. This might be interesting for us to have a look at. It's a little bit different from what we saw before. So similarity method works based on the vectors that we provide and a similarity score. So we have this query, which is basically I'm selecting top of items and I'm selecting only particular properties. So ID, user input, generated description, Taurus config, and preview URL. And then I'm using a vector distance method with vectors on vector property and applying my similarity score to this query. After this, so I'm also using this vector distance here, so everything that is bigger than similarity score, and then I'm also ordering by this vector distance, by the result of the vector distance method. So this is how the query looks like. So this is the simplest thing you can do. This is just a literally syntax that you can use for the similarity searches when you apply it for Azure Cosmos DB. So then you get this query definition, and then you can get items from that query definition. So you always have to build it, because then you build the query definition with the query that we wrote here, and then you pass the parameters in there. And then when it actually executes, you will be able to extract some items from the container. So then get design range async, and then get items query iterators. Those are very simple ones where we get some items out of it. Semantic kernel service. So this is the last one that we have, and then I'm going to start the application. Actually, I'm going to start it already. So I'm going to do it like this. So .NET Run. I want to start it, so it will have a minute to actually get up and running. So semantic kernel. So this is the configuration that we have. So I'm providing the configuration for chat completion model and text embedding generation with some properties. I mean, all of those things, of course, important, but we're not going to spend too much looking into the properties itself. Like, there is very good documentation. You can have a look at what all those properties mean, but the most important is that you provide the model ID, which is your completion deployment model name. And then you can provide some additional properties like amount of dimensions for your embeddings. So when we want to get embeddings, it's also quite simple. Actually, you just get the kernel and then get required service by the type of it, and then you generate embeddings out of it. When we want to generate design configurations, because we have to do different operations with different models. So first of all, I'm creating the prompt, and then I'm invoking the prompt description, this description that I have with the certain arguments. So this is basically how you can call certain functions when it comes to semantic kernel. You can create function from prompt, and there's more things that you can do. So let's try if there is IntelliSense. No, there is not IntelliSense. Okay. I wanted to show you, but probably it's running. So you can, it's not only that you have an option to create it from prompt, so there's much more to that, but this is one that fits my use case because I have those different prompts for different cases. So I'm first generating the description itself, and then out of the description, I'm generating the art config. So I have default configuration just in case. So, but then I'm using either the output or the art config, because when you're working with LLMs, you cannot rely always that it's going to give you expected result 100% of time. So then we can also search for designs, and that's basically it. So that's basically how the core logic of my application. Then just a quick look of the prompt on the prompt itself. So these are my prompts. The first one is like you are an assistant that transforms creative art prompt into a visual description and yada yada. So it's not very big, but it does a trick. And then design configuration prompt template is a little bit different because besides the prompt itself, it also has some guidance. So basically guardrails, what I should do, what I shouldn't do. Those are additional rules that are very important in this case, because if I will exit some of those parameters, the result will be really not nice. Like it will not be usable for me, for my purpose. So I had to provide those guardrails, and then I had to provide a schema on how it should look like, and then certain value like ranges in this case. So most of the time I will get exactly this output, but sometimes LLM will add some weird characters in the end of the output, and then my application will fail. This happens. I just didn't have time to actually fix it properly, but let's hope that it's not going to happen today. So now we have our application running. If I will open it, you probably will not see anything. Let's see if I have Swagger. Don't remember, to be honest. I do have Swagger, of course I do. So we have, this is how our endpoints look like, but we're not going to try them, because why should we if we have an actual UI that we can play around with? So what I'm going to do here, we are, I don't actually remember what's the npm, yeah, around there. So here is our application. I can open it here, but I like to open it in the browser separately. And this is how it looks like. So this is my application, and I keep changing it, and I keep making it nicer, or like changing some stuff, adding some pages. But this is the current status of it. So there is a home, which is actually the place where my visualization component lives. And then there is this is an input, and there's a few options. It's a clear, adjust, or generate. And then I can download the preview, or like the preview will be saved, or download the SVG file, not the SVG file, but object file that then I can use for my sketches. The only thing that I want to show you here, I think that might make sense, is an actual torus canvas. So the rest is just the page, right? So we're not going to spend too much time looking at the front end itself. I just want to show you how the actual, this is the visualization component, and this is going to actually render some stuff for us. So I'm using P5GS for this, and that's the torus canvas where all the magic is happening. If I'm gonna really simplify all that, it all comes to creating a sketch. And then in that sketch, we set the background, then we make a computation of node paths. So like how many circles and how many lines do we have to draw. And then we will compute rings first parallel transport. This method is responsible for all the modifications that I'm doing to a torus node. I will show you like different parameters that you can change and how they actually impact the final result. Then we have some camera setup, and because this is a 3D object, so I have it fixed. So at the top view of my torus node, but I can also rotate it if I will enable it here. And then I'm just making some filling, like color filling, like depth fill, and then drop the wireframe itself. This is going to be like the color, the main color we see here, blue, and then the wireframe is a white color. That's basically it. That's what's happening here. So that's a very simple and a very high level. But if you will have a look at the logic itself, then of course it's much more complicated. There is a lot of math in here. As you can see, like a lot of computations are happening. Even more here. So like a lot of sinus, cosinus. So I have to really remember, like I really had to think, sit down and play around with formulas and equations, and in some cases reverse engineer some of the logic to achieve the output, the result that I wanted. But now let's have a look at the application itself. So we have a gallery, and the gallery, those are all things that I generated in the past, and some of them I already used, and I already actually created some of the sketches. So this one is already actually implemented, like not implemented, but I do have an art in my workshop of this sketch. This one as well. So I used some of them that I like the most. And as you can see, I did quite a lot of trying and generations to see what I like or not. So when it comes to already existing shape, for example, this one I like a lot, and I might use it for my next artwork. These are all parameters that you can modify, and then if you do it like this, so let's say we take 200 because it's then a bit easier for browser to calculate. And then if you're gonna play with different parameters, this is gonna be the results that we're getting. So I can always come if I like the shape, and I can play around with it more and get different results. If I like it, I can click save, and then I will get the preview of it, and then I will have it saved in my Cosmos DB. If I don't like it, I can reset it, or I can download the object file. And object file is literally just a set of all the coordinates that I'm using later for my CNC machine. So when I take it, I then post-process this object file, and I can also use object file for 3D printing. I can convert it to STL format. I can use it for laser cutting, for anything. So this is how it looks like. And if I go to home, so I can basically play as much as I want. There's a lot of parameters. Oops, it's too much. Okay. There's a lot of parameters that I can change. Yeah, it was too much. Yeah. So I usually take quite some time to also play around here, but it's much more nicer for me because I already have a nice base. And if I go back home, I can also, like, these are related shapes because this is something that I generated before, and we can just try to generate something from the sketch. So I would like to have a nice, simple flower-like looking shape. I'm sorry, my fantasy is not working. Simple. It doesn't really work that well during demos. So I always basically, I use very similar prompt every time. But anyway, so when I ask for a nice, simple flower-like looking shape, it does a couple of things. I mean, of course, I could integrate a loader bar, but I know that it takes a couple of seconds because it sends a request to LLM. So what it does, it sends the similarity search and finds related shapes. So some of them, some of them probably had a very similar prompt. And then it also generates one for me, but it takes a couple of seconds to then actually get the result. So if I do want to do something with it, I can click adjust, and then I can play around with it even more, like as I did with the previous shape. I can download object file, I can reset it or save it. So that was my idea. I hope it all makes sense why I did it in this way. And the last thing that I want to show you is just a few things that I already created taken from my application. So these are all generated shapes, and I use them for CNC with my CNC machine, and those are results. I honestly did much more after, like at some point. So at some point, I started experimenting also with other shapes besides torus node. I also started using different algorithms, and I started expanding it more and more. For now, those are this is my favorite shape, this torus node. I think these were the last one that I did, and I didn't really do any more of torus node shapes, but I'm going to get back to it again because I really liked what I generated in the last couple of sessions that I played around with it. I do believe that we should be very close to the end of the session, right?
Yes.
Yeah, so I will tell you thank you. I hope it all made sense, and I never know if, like, what's the level of people that are listening to me. So I hope it made sense from all the perspective, from technical, but also from how you can apply your technical knowledge and then actually build something with it. Again, these are my contacts on the screen that you can follow me, connect with me, and ask some questions if you feel like. Thank you very much for having me. Thank you very much for listening. And if there are any questions, I'm still here.
Thank you very much for your high level, wonderful session. It's really, really very high level, for example, for myself, but it's very interesting. And I see there is no question, but one comment from Farooq who says, wow, so got very interesting, excited. So,
Thank you.
so I would like to thank you once again and best of luck. And
Thank you very much.
I hope and strongly believe that during this session you have got an email from Microsoft about your renewal process. When we
I hope
started,
so. I'll check it afterwards.
I got this email. I'm very happy. So I
Nice.
hope
Congrats.
thank you. I hope this is the same for you. So see you in upcoming events, either in person ones or in online ones. You do a great job. So I would like to thank you once again and to end our session here. So have a
Thank
good
you very
day.
much. Thank you.